our inequality symbol is going to, or our graphing symbol, is going to be an open dot. Now that means that the solution cannot be on that exact point. However, then we will shade, and when you're shading, if you want to just do it a little above the line, that's fine. You can go like this. You're shading from the solution point and then shading to the direction of the solutions. When writing an inequality, if you write the variable first, then the inequality symbol will go the same direction as, or the inequality shading will go the same direction as the symbol. In the case of it being less than, greater than, and equal to, then we would use a solid point. And because the solution set includes that exact point. And then again, shading to the left or the right of the point, whichever is corresponds with the less than or greater than. So if we go ahead and we look at our first story problem, Sue ran a 2-kilometer race in 8 minutes. So we're going to write an inequality to describe the average speed of runners who were faster than Sue. So we could have many different ones. We're going to go ahead and we're going to go with speed. It would be speed, you can read that, is greater than, maybe I'll just use my symbol, distance over time, or rate, speed or rate. I'll put an R in there. Rate is greater than the distance divided by the time. So we know that the rate of the average speed there is, we do not know that. That's going to be our variable. And the distance is 2, and the time is going to be for 8 minutes. So distance is 2 kilometers. Let me try writing that 2 a little bit fuller. 2 kilometers, and it was in 8 minutes. And so we're going to need an average time that's going to be greater than that. I'm going to just make it x just so it's easier to read on this. And so then we would say that x is going to be greater than 1/4. Okay, sorry. X is going to be greater than 1/4. So I'm going to go ahead and simplify my fraction there. To draw that on a number line, I'm going to, and this is what I will ask you to do in class as well, I'd like to see where the 0 point is. Our answer is in the positives, and it's going to be greater than that. So I'm going to put my 0 down here. I could then mark, let's go ahead and we'll mark tick marks for every fourth. So this is going to be 1, 1/4, 2/4, 3/4. You don't have to be this exact. Not that mine looks exact here by any means. So then I'm going to, it is greater than, so let me use a different color here so we can see this a little bit better. I'm going to go to this spot, 1/4. I'm going to do an open point. It'll let me do that. And then my variables first, it's pointing to the right. I want the answer to be anything greater than 1/4. So I'm going to go ahead and I'm going to shade to the right. Okay, moving on. We're going to go ahead and we're going to start solving some one-step linear equations. So we're going to do algebra. And in adding and subtracting, which you're going to do first, we are going to do the exact same procedure that we did when we were solving equalities or equations. So let's go ahead and move to the next page. If you need to, you can go ahead and read through that, pause and read through it. I'm going to put it into action in example 2. So x plus 5 needs to be greater than or equal to 3. So I'm going to go ahead and I'm going to get my constants together. So I need to subtract 5 from both sides. That would leave me with x. I'm going to leave my symbol the same. And 3 minus 5, going to be a negative 2. Okay, I believe I have this graphed here in my little pull method here. I do. So a couple things to point out. We have a solid point at negative 2. It's greater than or equal, so it needs to go to the right. And again, my variable is written first, so my inequality symbol matches the way that I'm going to shade. The reason we do this is any number that is greater than negative, that is equal to or greater than negative 2 would all satisfy this inequality statement. So let's go ahead and do another one here. This time my variable is on the right. So I'm going to do the same thing. I'm going to get my constant terms together. So I'm adding 4 to both sides. I get my n, if I can write my n. I leave my symbol the same, and negative 2 plus 4 would give me a positive 2. Now, I'm going to caution you that this seems like a silly step, but I would go ahead and I would rewrite the sentence. My n needs to be less than 2. Again, if you have to think about what you learned in grade school about the alligator and the eating and whatever all those things are that I learned, that I hear you say, but make sure the symbol is still accurate. It was pointing at the n. It needs to point at the n when you change the order. Again, when you write the variable first, it's a double check for you to look at the shading of your graph. So a couple of things before I reveal the graph. We have a less than symbol, so that means we're going to have an open dot, an open point, and we're going to make sure that it's shading to the left. So let's reveal that. Open circle at 2, shaded to the left. All right. Now, moving on to multiplication and division. In multiplication and division, we have one special rule that we have to remember, and that is when you multiply or divide each side of an inequality by a negative number, you need to make sure that you reverse the inequality symbol to make sure that it stays a true statement. Okay, so if we look at just the chart here, we have 1/2 x is greater than 3. We know that we would need to get the variable to be a single variable, solve for a single variable. So we're going to multiply both sides by 2. Inequality symbol stays the same. If we jump down to the third one, negative x is less than 4. We need to multiply or divide by a negative to make sure that we are going to get a positive single variable. So if we multiply each side by a negative 4, negative 1, you're going to notice that the symbol then reverses. The same thing is true in the last example. Negative 2x is less than or equal to 6. I'm going to divide both sides by a negative 2. So multiplying or dividing by a negative tells me I need to reverse my symbol in the solution. So let's put some of these into action. So the first one, a divided by 3 is less than or equal to 12. I'm going to rewrite this one just so you can see that I am. Okay, my a that turned out looking like a u. So a divided by 3, solving for a single variable. This is all very simple, going back to some old routines here. We are going to get that a is less than or equal to 36. I didn't divide or multiply by a negative, so I left my symbol the same. And we'll go ahead and reveal the chart before I do, or the line. Before I do that, we notice it's a less than or equal to. It's going to be a solid point, and it's going to be shaded to the left. There's our solid point, shaded to the left. Excuse me. Our next one, we're going to need to divide to get our single variable. I'll try to write it right on here. I'm dividing by a negative, so I need to remember to reverse the sign. When I do that, I need to reverse the sign. So that's going to cancel each other out, giving me an m, my single variable, but reverse the sign because I divided by a negative, and then 6.3 divided by a negative 4.2. Don't lose your negative signs. will give me a 1.5, negative 1.5. Again, a reminder, it's a less than symbol, so it's going to be an open point, and our variable is written first, so it's going to be shaded to the left because it is representing numbers that are less than negative 1.5. And that actually concludes 6.1. If I can get the recording to